This is Josh White with JW Math Tutoring. Today's video is going to look at the 6 hardest problems from the December 2022 ACT Math exam, Form F07. So let's go ahead and take a look.
But life is a dream the calculus could never predict.
Just before I begin this video, going through these 6 hardest ACT problems from this test, I just want to mention a couple things. First, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Second, the reason I'm only highlighting 6 problems from this test is because I've gotten hit with copyright strikes from the ACT when I published full reviews of completed official tests. So that's the reason why you only see 6 problems instead of the full 60, which I would love to do, full videos on. Lastly, if you're looking for more ACT practice work, please check out my Improve Your ACT Math Score course. You can find it on Udemy. You can find it also on Teachable. There are direct links to both courses in the description of this video below. And basically, this is a comprehensive overview of the math section on the ACT. It covers your common topics in algebra and geometry and probability and statistics, in addition to strategies like backsolving, picking numbers, process of elimination, estimation, drawing a picture, essentially in order to help you solve problems as quickly as possible. And it also includes an entire module on using the TI-84 graphing calculator to solve problems as well. Basically, it features over 10 hours of instructional video along those 5 different modules. So please do check that out. Anyways, here are the solutions to these 6 hardest problems. Okay, now looking at number 30 at the bottom of the page here. Here you have a problem that deals with basically permutations, a topic from statistics and probability. So if you're not familiar with permutations or the formula for permutations or the slot method, then you would probably have difficulty answering this question correctly. So basically what they're looking for is, here, how many ways can we line up the now 10 treats that the company has? Because if you go back and read the information in the problem here, right, notice that we have originally 3 cat treats and then 4 dog treats. So we have 7 treats initially. And then, so that would be, you could say, like, without, gerbil, there's 7. But with the 3 gerbil treats, there are now 10. So to find the number of ways you can line up 10 items in a row on a shelf, essentially it is going to be, for permutations, it's just 10p10. And now if you know the formula for permutations, that's just going to be 10 factorial. Technically it's this number. And then on the bottom, it's first number minus second number, n minus r. So 10 minus 10 factorial. That's just 10 factorial over 0 factorial. 0 factorial is just 1. So in other words, the number of ways you can do it is just 10 factorial. Now, if you use the slot method, you get the same answer. All right. It's basically just like 10 options for the first, and then you have 9 options for the second spot, 8 options for the third, 7 for the fourth, blah, 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 blah. And then eventually you get down to 1. And if you notice, you multiply these all out, 10 times 9 times 8 times 7 times 6 and blah, blah, blah to 1. That's just 10 factorial. Okay. So whether you use the slot method or the permutation formula, you get the same expression, same answer. Okay, so now just because the calculator is covering it, let me just actually rewrite it down here to do the without gerbil calculations. So this is going to follow the same pattern where it's going to be, for the permutation formula, 7p7, which would just be 7 factorial over 7 minus 7 factorial, which again would be 7 factorial over 0 factorial, which is just 7 factorial. And if you use the slot method, again, following the same approach, it's going to be 7 options for the first, times 6 for the second, times 5, times 4, blah, 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 down to 1. Again, that just simplifies to 7 factorial. Now, they want the difference between these. So they just want 10 factorial minus 7 factorial, and that's it. So the correct answer to this is letter J. Now, one thing I will say is if you actually go to your calculator and you type in, 10p10 and get the answer, and then you type in 7p7 and get the answer. Okay, you're going to have some numerical value, but notice these are expressions. So then what you would have to do is you would have to start, say, with f, and you would have to type in 10 factorial divided by 3 factorial, and you would see, does that match what 10 factorial minus 7 factorial is? Okay, and it doesn't, so therefore you could cross it out. And then you could go to G and you could type that in and you would see it doesn't match. And then you'd go to H and you type that in and blah, blah, blah. And eventually you would see that J matches. But again, that just basically that adds extra time if you actually do the calculation out rather than just leaving it as, 10 factorial and 7 factorial. But again, this covers concept of permutations. Now at the bottom of the next page here, question number 41, we have one that deals with logs. So first, I will show you the theoretical way to solve this. Then I will show you how you could just use the process of backsolving to solve it entirely on the calculator. So the theoretical way to solve this problem is to replace the d value, which is the number of decimals, with 100. And then essentially, first divide by 10. Now, you do need to know the properties of logarithms in order to simplify this. So notice there's no base written here. That means we assume the base is 10. Now you would rewrite this in exponential form because we know the base to the number that's alone by itself is equal to what's in the parentheses. So in other words, 10 to the 10 is equal to I over 10 to the negative 12th. Now what I would do is I would take this negative exponent and I would flip it to the top and it will become 10 to the positive 12th. And then you could divide by 10 to the 12th. And now this is just going to become 10 to the negative second, or just basically 0.01. 10 to the negative second, because you subtract your exponents, or again 0.01. But again, all these answers, well, at least the first three are all given in scientific notation. So the correct answer for this one is going to be letter A. But now let's see how you could solve it in just by entirely on the calculator. So essentially what we're going to do is I'm going to plug in these answer choices starting with A for I. And then I'm just going to see, does it give me 100 when I calculate it out? So this is a basic, skill that you should know how to do where even if you're dealing with logs and you don't know what log is, you know that there is a log button here that you can still, do a function of a logarithm. Okay, so now obviously it takes me a little bit longer to type this in because I'm using an on-screen calculator rather than, you're punching it on a physical calculator. But notice when I type this in, it gives me 100 as my answer. That is the number of decimals we're looking for, so that would tell you that letter A is the correct answer. Now, if it wasn't, then obviously you'd move on to choice B. And again, you can just copy and paste the last line here, hit second, enter, and now you could just go up here. Okay, and if you wanted to make this into 22, well, just change that, and now you could hit enter. Okay, notice this is 340. That's not the answer we're looking for. Obviously, it's wrong, but the point is you don't have to retype the entire expression. Okay. At the top of the next page, we have question number 49. So this problem, they want to know basically the measure of this arc right here. So there are a couple different ways that you could figure this out or think about it. So I'll go through the various different ways that you could get this answer. All right. So one thing to notice is AD is a diameter. They give you that in the problem, okay? That means that this is a right angle right here because, well, for two reasons. First of all, any triangle inscribed with its diameter as the essentially, on the circle here, inscribed in a technically it's any triangle inscribed in a semicircle, which is what this is because AD is a diameter, means that it's a right triangle. So this angle up here, angle ACD, is a right angle. That means basically this right here is 180 total degrees. That means AE is 120 degrees because of 180 minus 60. Therefore, you can now figure out ACE by just doing 360 degrees, total degrees around a circle, minus 120 and getting 240. All right, so the correct answer for this is going to be letter C. Now, if that's not obvious to you, I mean, what some people would do is some people would basically add these three up. 60 plus 70 is 130, and then plus 120, and that should give you 250, and then they would subtract that from 360, and you get 110 for this over here, and then you could add up 110 plus 70, which is 180, and then plus 60. Now, alternately, you actually don't even need to do all that because, as I mentioned earlier, if you recognize, let me just erase all this, if you recognize that AD is a semicircle, um, then that means this total arc here from A to D is 180 degrees, obviously. So therefore, this whole thing's 180, and then you add 60, and that gives you 240 as well. Okay, so that's an alternate way kind of to think about it or to figure it out. I think that's probably all that there is to demonstrate. There's other more complicated ways, figuring out like how much this angle is because this is 35 and this is 90. So you add those up and then this turns out to be 55 and going from there. So you could do that as well. But I think kind of the first two or three ways to demonstrate it are how I would attack this problem. All right, next, let's look at number 50. So the next one below it. Here they tell you it's actually a right triangle. So if you didn't know that, you actually could have just read ahead and whatever. They tell it to you in the next problem. All right, which of the following represents the length of AC? So, and they give you a bunch of expressions with sign and everything, right? So what I would do is I would basically recreate this picture. It's 90, okay. Out here, we know AD is 12. Okay, we know this is 12. Now, the whole key to this one is knowing that this angle down here will be 35 degrees. The way that you know that is because this is an inscribed angle, angle D or angle CDA. Measure of an inscribed angle is half the measure of its corresponding arc. So the measure of angle D will be 1/2 of AC, the 70-degree arc, or in other words, 35. So now that you have that, you can easily find the measure of AC, in terms of a sine and in terms of a side here, right? Basically, the sine of 35 degrees is going to be equal to its opposite side, which is AC, over the hypotenuse. Hypotenuse right here is AD, the diameter, which is 12. And now you just multiply this across, multiply both sides by 12. So what is AC equal to? It's equal to 12 sine 35 degrees. Correct answer here is going to be letter J. All right, last, let's talk about 51 here at the bottom. So basically, if you start moving E along the circle in a counterclockwise direction until it reaches A, what happens to the length of line segment CE? That's what they're asking. So this one is a little bit tricky. So E again is moving in this direction. Basically, notice that right now, okay, CE is not a diameter because it does not go through the center. And the diameter is always the longest chord in a circle. Any other chord which is not the diameter is going to be shorter than it. So right now, CE is not a diameter, so it's less than it. However, if you move E over here just a little bit, so that you now have C going through B and then going through E. Now it's a diameter. Therefore, the length of CE when it goes through B, it would be larger than its original length when it does not go through B. So initially, the length is going to increase. However, once you keep moving, you should notice it's going to get smaller, and smaller and smaller. Okay, because CA is obviously much smaller than the diameter of the circle AD. So it's going to increase initially, but then decrease after that. Once it gets past, point B or through point B, the center of the circle, um, and just keep getting smaller and smaller. So the correct answer to this one is just going to be letter E, increase and then decrease. Next up, question number 59. Here we have a problem where picking numbers is a great strategy to basically plug in numbers for A and B and determine how this number line, can work out properly. So these are the answer choices are the possible values for B. So what I'm going to do is I'm going to start, I'm just going to make a little table over here. Actually, we'll just do it underneath we'll just do it straight underneath the number line. So first thing, my B values, are just going to be the answer choices themselves. So if I start with -2 for B, A has to be less than that. So let's make A -3. Now, if you try to do the square root of -3, that's going to be a complex number. That's not going to be a real number. So this answer choice isn't even possible. You know what I mean? So we can just go ahead and cross this one out. Next, if I start with 0, again, A has to be a negative number. So if you just pick -1, for example, then again, the square root of that is just going to be a complex number, not a real number. So this answer choice, again, doesn't work out either. All right, now we have 3/7. Now, 3/7 as a decimal is like 0.42857. So we just need some number smaller than that for our A. So I'll just go ahead and pick 0.4. So now I need to do the square root of that. And that's going to be the other number. Okay, so 0.6325. That's going to be the other number on our number line. So notice right now, all of these numbers are in the correct order on a number line, with the smallest on the left, the largest on the right, and the number in the middle is between both of them. It's 0.4, 0.42857, and 0.6325. So this looks like the correct answer, but let's just check D and E just to confirm that they are not correct. All right, so for 1, there's multiple ways you could eliminate this. So you could you could just pick a negative number, say like -1, because if you plug that in, then this would give you a square root of -1, which is a complex number, and you could rule that out. And you could do the same thing here, because the only requirement again is that the A value has to be less than B. So you could pick negative values for this one, for E as well, and you could rule that out. But just to show you, just to pick some positive numbers, just to show you how it actually works out, that these are wrong, I'm going to pick, 0.5 here for D. And so if you do the square root of 0.5, okay, we get 0.707. So notice now 0.5 is less than 1, that checks, but 1 is not less than 0.707. So this one does not work because the numbers are not in the correct order on this number line. All right, same thing is going to be true for this. Say I pick 2 as my A value. So now I have the square root of 2. So I just go ahead and calculate that out to 1.414. And again, the numbers are not in the correct order. 2 is less than 9/4. 9/4, by the way, is 2.25. But 9/4, or 2.25, is not less than 1.414. So again, the numbers are not in the correct order on the number line. So C is the correct answer here. And the reason it has to be C is because technically, in order for this to work, the B value has to be a number between 0 and 1. And the whole reason for that is because you want a number for A which is between 0 and 1, and we obviously need a to be less than b. And the reason we want that is because numbers that are between 0 and 1, when you take the square root of them, the square root of the number is greater than the number itself. And you can try this out with pick any number between, um, you know, anything between 0 and 1, from 0.0001 up to, 0.999. You take the square root of that number, and the answer you get will be larger than the original number that you started with. So that's what happens here that's how you get the root a here on the right side to be greater than the a on the left side. And the reason it has to, and then also the reason it has to be c is because if the a value is a number between 0 and 1, and therefore the root a is a number between 0 and 1, then b has to be between 0 and 1 as well. So that's how you basically meet both conditions of the problem to make the numbers line up in order. Okay, so that's kind of the theory behind this. And if you don't understand that, that's fine. Just, follow the picking numbers approach where you pick numbers for B, then pick a number for A, find the square root of A, and you see which one, makes sense or which one has the numbers in order. But that's kind of the theory for why it has to be 3/7 as the correct answer. If you enjoyed this video, if you have any questions or comments on these problems, please do leave them below. Otherwise, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. And of course, as I mentioned earlier, check out my Improve Your ACT Math Score course if you're looking for more resources to help raise that ACT math score of yours.